Today we will study work. So what is work? Is that work is defined as the product of net force acting on a body and the distance moved in the direction of applied force. This is called work. What is the formula of work? Work is equal to force into parallel distance, which means W is equal to F into D. Now what is the SI unit of work? The SI unit of work is joule. 1 joule is equal to 1 Newton meter. Now suppose that the force does not act parallel, means in the direction of displacement force does not act. Force is acting with the horizon at an angle of theta. Then the work is equal to F cos theta into delta x. Delta x is the displacement. Why this F cos theta is there? We have to calculate the component of F in horizontal direction. So the component of F in horizontal direction it is F cos theta. So the general formula for the work is W is equal to F cos theta into delta x, where F is the magnitude of the force, delta x is the magnitude of the object's displacement, and theta is the angle between the force and the displacement. Now the cases depending upon the value of theta. Suppose that if theta is equal to 0, then cos 0 is equal to 1, then W will be equal to F into delta x. This is the maximum value of work, and this work is called motive work. Next case, if theta is 90 degree, then cos theta is 0, cos 90 is 0. So W will be 0 means work will be 0. Means if you are applying the force in such that the displacement and force are perpendicular to each other, then no work is to be counted. So this case is so important, so keep in mind that work done by a normal force when this force is perpendicular to the direction of motion, that is 0. Third case, if theta is equal to 180, means you are applying the force in this direction but the displacement is opposite. So the angle between them, that will be 180 degree. So cos 180, that is minus 1. So minus 1 means the work will be negative. This force is also resistive, means this force is resistive force. Work done by force of friction, means if the work is negative, then this work is called the work done by the frictional force. The next thing, the work done by the gravity. Work done by the gravity. The work done by a body falling under the action of its weight only is W is equal to mgh. M is the mass of the body, G is gravity, and H is height. Cos 0, leave it. So the general formula of work done by the gravity is mgh. M is the mass of the body in kg, and G is acceleration due to gravity, and H is the height. Whatever the path followed, the displacement is the shortcut distance between the two levels. Okay? Now let's see, the work done may be positive or negative. Means if you are lifting the body, means applying the force against gravity, then the work done will be positive. But suppose that work is positive when lifting the box, and work would be negative if lowering the box. Got it? Now let's see the unit of work. Important term, SI unit of work, that is joule, and CGS unit of work, that is erg. Joule also can be written Newton meter and erg centimeter. Now relation between joule and erg. Let's see, SI unit of work is joule, that is Newton meter. CGS unit of work, it is erg, that is centimeter. Where 1 Newton is equal to 10 raised to power 5 dyne, and 1 meter is equal to 100 centimeter. So that 1 joule is equal to 1 Newton meter. So instead of 1 Newton we can put 10 raised to power 5 dyne, and instead of 1 meter we can put 100 centimeter. 10 raised to power 5 and 10 raised to power 2, that will be equal to 10 raised to power 7 erg. So 1 joule is equal to 10 raised to power 7 erg. Learn this, it is important. The numerical of work. Suppose that two persons apply equal force, that is of 500 Newton, on two different bodies, that is of 300 kg and this is of 100 kg. This man applies a force but there is no motion, means no movement, and in this the body travels 6 meters. So what is the work done by this man? That is, work is equal to force into distance. The force is 500 Newton and the distance travelled by the body, that is 0. So the work done is 0 joule. But in this, the force is 500 Newton and distance travelled, that is 6 meters. So the work done is 300 joule. Let's take another example. In this question, we are going to know the potential energy gained by the body as well as the work done. Both are the similar thing. See the question. A load with a mass of 5 kg was lifted up by a pulley to a height of 0.8 meter. This is M, this is H, and G is given 9.81 meter per second square. Suppose that you are being questioned what is the work done. So work done is equal to mgh. So M, that is 5 kg, G, that is 9.81, and H is 0.8. So the answer is 39.24 joule. The similar question may be asked for the potential energy. So potential energy, that is also mgh. The same answer will be there. Let's see some question for your practice. I am convincing you only. First question. An object is moved with a force of 15 Newton. This is F. Across a horizontal surface, how much work is done if the object is moved by 50 meter? This is D, this is F. So W is equal to F into D, means 15 into 15, that is equal to 750 joule. Next question. 650 joule of work is done in moving a desk in a horizontal distance of 5 meter. How much force is used to move the desk? This is W, this is D, you have to calculate F. So F is equal to W upon D. So 5 ones are 5, 5 threes are 15, 0. So 130 Newton. That is the value of force. Now how much work is done in lifting 10 kg? Means M is 10 kg box, 1.5 meter of the floor. In this question, let G is 10, mass is 10, and the height H is 1.5. So W is equal to mgh, 10 into 10 into 1.5. So that is equal to 150 joule. See, in this table, see force, distance and work done. So you have 5 set of question and you have to fill the values. In this part, force and distance are mentioned, calculate work done. In this, force and distances are mentioned, calculate work done. In this, work and distance are mentioned, you have to calculate force. Similarly here, force is to be calculated. In these two parts, forces and the work done by them are given. You have to calculate the distance. This is your homework.